In that case, let's...
All I know is my y-axis pulled too much current inside.
Okay, let's reverse out of the process, at least until we get the fork back out. Okay. Then let's look at the clamp as it's seated, make sure everything looks fine.
We literally have a week for this thing to be up and running.
In additive manufacturing, specifically metal additive manufacturing, after the printing process, over half of the cost of producing components still exists in the finishing of those parts. Those are the bandsaw cuts, the wired EMs, the heat treats, the machining, the finishing, the plating. So we've done a lot of work at looking at what are the benefits when we tie these processes together. So this is a new system that we're developing for IMTS this year.
Future Foundries is a concept platform of a next generation convergent manufacturing platform. What they're going to see is machining, induction heating, welding, and scanning. What we're demonstrating is not necessarily the fact that we can do all of those processes, it's about presenting the idea and the concept that we can integrate them together in a new and novel way.
So we have a lot of partners involved with this project. One of those is Akuma. So we're going to be shipping it to that warehouse for the final integration, and we're going to be developing our demos for the trade show. And then from there, we're going to ship it to the McCormick place in Chicago.
The system that you see buried behind me was actually a demonstration unit that was sitting in Akuma's showroom. Tom and a few of the Oak Ridge folks were touring Akuma, trying to figure out what was the next best thing to do for IMTS, and they saw our system. For us, we have to interface both the Akuma and the equipment that Oak Ridge is providing and make sure those interfaces are working, because we are the brain, if you will, of the whole system. Our system is being utilized in a way that it was never designed for. But that's a good thing, because it's opening up boundaries, and it is giving FASTMs a good look into the future.
Once we kind of get our stuff operational, then it will be, that is the last puzzle piece.
Yeah, game on.
And it's the one I'm the most nervous of, but no, it's gonna look good.
If you're trying to establish a new system, particularly one that's multiple subsystems communicating with one another, the difficulty there is that you have to exactly specify what those robots are going to do. They're only going to do exactly what we tell them to do, nothing more, nothing less. So we have to program all that intelligence into the system itself. So for each of these cells, we have to do that, and then they have to be able to communicate to one another in a way that's clear as well.
We're trying to lift up, and we got an overload, basically. Motor, too much current.
It did send the unclaimed signal. Okay, so it's a different problem.
Yeah, that's what I was worried about, is the level. Because even if we have space on the front, do we have space in the back?
Once we're in here, right, we don't really have something that won't get in the way of the robots. So the best option that we came up with was putting it on the tip cleaner, probably. Clearance profile should be at least 2, so yeah. That should buy us enough space.
It is right now.
We're good. We're good. Nothing without risk.
Everybody here, you would really consider just a genius at what they do. We've been at this for about 3 months, preparing for IMTS. We're down to a week, and there is still a few things to tidy up and define, but completely confident that that'll happen. There'll be no issues once we get to Chicago.
The platform's working. Yesterday we finished the last of the system integration to demonstrate how they can all cohesively work together. But we're really excited and we're ready to show our new platform off to the public.
We are at IMTS 2024. It's the International Manufacturing Technology Show. Anything for manufacturing technology, it is here. Whether it's machining, additive, lasers, it's all here.
It's incredibly important to be here at IMTS because we get to meet with a lot of industry and people that are doing manufacturing. And as the front door to the Department of Energy related to manufacturing, the MDF really values this experience.
The role of Oak Ridge National Lab, and specifically its manufacturing demonstration facility, is to bring companies together and work on a larger manufacturing challenge, and that's what we're doing with the Convergent manufacturing. It's not just additive in terms of wire arc, we're also doing the heat treatment, the machining, the metrology, all the things that you're going to have to do to make real products. Through automation, we can actually package that, make that one, Convergent. And I think that's what's really going to take additive to a whole new level.
I would say that the journey has just begun. Over time, we will update, we will change, we will modify, we'll add a whole bunch of different technology, and I think in 10 years this will have a completely transformational change on the industry.